Alright, welcome back to my next LeetCode video where I pick a random LeetCode and you join me as I go through and I show you my process from the first time seeing a problem to trying to solve it optimally. Sometimes I can't solve it myself, so in that case we'll look through the optimal solution and we'll see what mistakes I made, maybe some things I can learn, and hopefully some things that you can take away from the experience too. Alright, so yesterday we did a hard problem which we actually nearly solved, but it was just a bit too time inefficient. But we looked through the solutions and we figured out how we could have improved it. But today I think we're going to take it back to an easy. We haven't done an easy in a while, so hopefully this will be a quick video. Hopefully I've learnt a bit from some of the LeetCodes I've done. Alright, so let's pick a random easy. Alright, this is a SQL one. We actually want to do some more algorithm questions, so we'll pick a new one. Did I press the wrong button there? I'm not sure what I pressed. So easy. Oops. Pick one. Alright, that looks right. Let's start a timer before we start reading and let's go. So 2660. Determine the winner of a bowling game. You are given two zero-index integer arrays, player 1 and player 2, that represent the number of pins that player 1 and player 2 hit in a bowling game, respectively. The bowling game consists of n turns, and the number of pins in each turn is exactly 10. Assume a player hit xi pins in the ith turn. The value of the ith turn for the player is double if the player hit 10 pins in any of the previous two turns, otherwise it is just xi. The score of the player is the sum of the values of their n turns. Return 1 if player 1 wins, 2 if player 2 wins, and 0 in the case of a draw. Let's just write that down in a few more concise comments here. So 2 int arrays, player 1 and player 2. Right, none of pins that they hit in a game. So let's see. Okay. And there are n turns, 10 pins in each turn. If a player hits x, just call it just x, pins in the ith turn, it is worth double. Worth double if it's 10 in any of the previous two turns. Okay. Total score is sum of the values of their n turns. Return 1 if player 1 wins, 2 if player 2 wins, 0 if draw. So let's look at some of these examples. So here player 1 hit 4 pins, 10 pins, 7 pins, and 9 pins. So I'm guessing if we go through that, the score is 4 plus 10. And now when they bowled a 7, they got 10 in the previous one, so that's 14. So that's 28 in total. And then in the fourth turn they got 9 pins, but as they got 10 pins 2 turns ago, that would be 28 plus 18, which would be 46, I believe. 28, yeah, 46. Yes, that's what they say. And now here, oh, there's no 10s, so we don't have to worry about any of that. So it would just be 6 plus 5, 11 plus 2, 13 plus 3, which is 16. And now we compare player 1 and player 2. Player 1 score is more, so player 1 wins. Alright, I don't think we need to check any of the other examples. They're pretty simple. The constraints and can be up to 1,000. They can have 1,000 turns. Well, so it has to be fairly efficient. So my first thoughts, would be keep track of scores on each player. And then for each element of every player's what do you call it? I don't know. Pin array. We would actually. No, I'm not sure that wouldn't work. I was going to say we can just iterate over these vectors, and if we come across a 10, we double the next 2. But if we come across 2 10s in a row, then we would be in trouble. We can come back to that after this. But it's just for each. We'll do a brute force here. Just for each element in the player's pin array, add check if any of the 2 previous turns were 10. If so, add double the current element to the value. Else, don't double. And then do that for both, and then return max. So let's see if we can do that. So we want to keep scores of each player. So we will just initialize them to player 1 score equals 0, player 2 score equals 0, 2, and then we want to iterate over each one. So for I equals 0, that's the player. We'll do player 1 first by itself. The only problem is checking the previous 2 when we're at the first one and the first 2. So we would do, or just a general case and we can fix it. So you'll get to the edge case after. We'll just do this first. So if player 1, I take 1 equals 10, or player 1, I take 2 equals 10, then we would do player 1 score plus equals 2 times player 1 I, else player 1 score plus equals player 1 I. And now to deal with the edge case, I guess we can start this from 2 and just check the first ones. So we already know that there's not going to be a 10 before the first turn, so we can just do player 1 score plus equals. Actually, no, we can just do that at the start, can't we? Player 1 0 and the same there. 0, because you can't. There's no case where that would be doubled even if it's 10. And then for the second one, we only have to do that one check. So we would do if player 1 score, not score, player 1 0 equals 10, we would do player 1 score thingy 2 times player 1 1, and we'll do the same thing for player 2 and we can also do that in here as well. Player, just change these all to 2s, and that should work. And now we do if oops, player 1 score is player 2 score, return 1, else if player 2 score is 1 score, return 2, else return 0. And let's submit that. Hopefully that should work. I'm trying to get this done in less than 10 minutes, so that's why I was rushing. Oh no, it's not correct. So what have we missed? Oh, that's why. Is that why? No, that's not why. Let's see. What have I missed? I've missed the 10-minute deadline, but what have I missed here actually? So just do init scores. If the first score was 10, we add double the second score. Same thing there. And for each turn, if either of the previous 2 turns were 10, add double the current 10. That's correct, is it not? Yes. So what have we done wrong here? Let's run that, see what the test cases say. Okay, so what seems to be the issue? Player 1, so for some reason this has been detected as player 2 winning, which it shouldn't do that, because we start player score, player 1 score equals 2 at the start, and player 2 score equals 0. Well, it also depends the size of the frame. So if the size is only 1, then we will just do this in there, because we can just exit early, but that's not the case here anyway. Interesting. So I noticed that the size is 2, so I think maybe this loop messes up here. But surely we get for an I equals 2, I is less than the size, so it won't work, right? Maybe I don't want to use print statements already, but let's think. If sorry, one turn in the game, what am I not seeing? I'm scanning every line and I'm not seeing the issue. I'm not sure what the problem is. So when it's 2 and 3, it will go player 1 score equals 2. That's not true. So we move on to the next one. And then if player 0 equals... that's why. Because we still have to add the score anyway. Oh, that's annoying. Whoops. That's pretty obvious. Yeah, that's it. So at 15:27, I click that submit button. Alrighty. So it's 15:29, but I'll say 15:27. I think we can improve this a little bit, but let's see. Submit it. Taking out, it's 15:27. That's annoying. Now, I'm just curious, do we need this part? I believe so, but we can also remove that into these. Oh, I'm not sure actually, but if we just remove that and run it, what happens? Oh. Double check there. So I'm not sure that will work, because what if it tries to access that? Yeah, no, it won't. Yep. Anyway, we forgot to analyze the time complexity of this approach. So the time would equal big O of n. I am 100% sure, because all we are doing is iterating over player 1 and increasing player score. Yes. Yeah. It's just that we have to check previous to every time, but that doesn't increase with n, that's constant. So it is just n. Space is big of 1, because we're just adding the 2 scores here. I mean, I suppose if these vectors were super massive, oh no, I was going to say player 1 score might be so big it would have to be used differently, but no, that's incorrect. So we've got a time complexity of big O of n and space of big O of 1 for this approach. I'll just add the comments just so it's easier to read. Turn winner slash draw. Now, is there anything else we can improve here? I don't believe so. Just for anything we can possibly find, I'm not sure. Why was that so much lower? We didn't change anything. I guess that's just how it works sometimes. But See, why was that so slow? Why is it so slow? And this one is pretty quick. Maybe it's these if statements here, and instead we could have just gone something like that. Yeah, recalculating the size every time. Let's just see if we can sneak some optimizations here. Store size of arrays. So just be that. And now we'll just put n in all these ones. Whoops. N and n. And run that. That looks a lot quicker. But that's only for 3 test cases. What am I talking about? I wonder if that's quicker. Yes, that's much faster. Look at that, beats 98%. Now the memory though is a bit weird. Why is that? So not as good. Maybe there's a way to do it without storing these things. I am just curious. I've never tried this before, but what if you put in right before returning, you put in delete and delete the stores. I have no idea if this will work. I've never tried this before. I'm just curious now. Surely that will give us all our memory back, right? No, so I guess that's just like for pointers and stuff. Something like that, or objects, I mean. I just wanted to try that, but let's see, how can we save more memory? Maybe there's just some sneaky C++ users doing better things. How else could we solve this maybe then? Because we've only been 20 minutes, so I'm not sure. I think that's the best we are probably going to get. Let's look at a solution, see if there's anything better. Alright, I guess that's how you do it with less storage. Oh, is it? No, it's not. Maybe we don't need these else's. I think that gets optimized by the compiler anyway, but whatever. So what they did was for each score in the player, oh no, that's being too tricky. What's F mean there? What does F mean? What's the update flag? F must be the update flag. I'm not sure why I've called it F. But if it's one would do G. That is not a very simple to read code. Where are we? There is no way that beats 100%. That's slower because you're doing 2 pass-throughs. I don't believe this for a second. Whoa, look at the memes. I fear not the man who has practiced 10,000 kicks once, but I fear the man who has practiced one kick 10,000 times. Yeah, I mean that makes sense. You would want upvotes, wouldn't you? So mine does it in one pass through, so I'm the winner. I think my solution is pretty darn tootin'. Alright, well, we had a pretty quick one. I'm not sure why it's slower than the rest. I'm not used to LeetCode, so maybe it's just me. Maybe comments and stuff make it slower. I wonder if that's true. Let's just test it. Because we got time, because we solved that pretty quick. Let's just remove them all. And that one. Let's see if it's faster. I mean, uses less memory. Either way. No. That was an experiment. Oh well. Not too shabby, Alonso. Why is the speed different there? I wonder. I don't know, maybe there's no way having the else's quicker. They would get optimized to the same thing in the end. Oh well. Thank you for watching this. Hold on, where's my quick one? I want my quick solution. Alright, we'll put the else's back in just for readability anyway. And because I like having the beats 98%. Whoops. 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 I would have thought that wouldn't change the speed though. No, it doesn't there. Maybe it just depends on like the servers and stuff. Anyway, thank you for watching this video. If you enjoyed it, please leave a like, comment any feedback you have, all the good stuff like that. I hope you enjoyed, and subscribe if you want more. And I'll catch you in the next one. Alright.